Hey fellow problem solvers, Colfax Math here. Today we're working on our math test success book, chapter 13, Quadratics. It's a pretty tricky chapter, but I'll be there every step of the way. You could get this whole book online. Just go to mathtestsuccess.com, download the book. It's all free of charge, and then work your way through this whole book with me. There are 25 chapters. There will be 25 videos. I'll walk you through every chapter, and we'll do it together. The key to doing well in math, just like the key to learning juggling, is practice. You can't just sit down and watch a video. You got to have paper and pencil out. You have to practice. You got to do the problems. Best way to do this is have the book in front of you, kind of fill it in, put notes in there. As I'm talking, you think, oh, that's a good idea. That's really a key thing. And write it down. And then pause the video and do the problems before I do the problems. And then unpause, watch how I do them. The key to success on any standardized math exam is to be well prepared. The way you prepare, again, is to practice. So let's go ahead and get started with quadratics. This is a pretty tricky chapter as well. If you did not go through chapter 12, polynomials where we factor, that might be a good chapter to review before we move on here. Okay, a quadratic is a special type of polynomial. It is always a second degree polynomial, meaning the highest exponent in it will be a 2. It'll always have 3 terms in it, ax squared plus bx plus c. Remember that a and b and c here are representing coefficients. So this is a general example. So it'll look something like 3x squared plus 4x plus 5 or something like that. But it'll be something x squared plus something x plus something. You could solve quadratics in a few different ways. The best way to solve a quadratic, and the easiest and always the first way you check, is you get the quadratic in general form, setting it equal to 0. So that means you get ax squared plus bx plus c all on the left side, set it equal to 0, and then you factor. And then once you factor it, you need these two terms multiplied together is equal to 0. So that means either the first term equals 0, or the second, or possibly both. From there, we're going to look at the quadratic equation. Okay, so let's start at section 13.1, solving quadratics by factoring. Again, the key here is to get it in the general form. Something ax squared plus something x plus c equals 0. Then you want to factor it, and then you want to use the zero sum property to say that each factor could or is equal to 0. So those are the steps. Let me walk you through these two examples here. One thing is I use a little bit of different notation throughout the book, but this right here means the exact same thing as x to the power of 2. So that little caret is saying to the power of. So I have x squared plus 5x plus 6 is equal to 0. First thing I want to do is get all my terms in order on the left and have it equal to 0. I'm already there, right? I have my x squared term, my x term, and my singular term, and it's set equal to 0. Now I'm going to factor that. The only factors of x squared are an x and an x. Factors of a 6 are a 6 and a 1. I could do 6 minus 1 to get a 5, but there's no negatives here, so that's not going to work. So the other factors of 6 are a 3 and a 2. I'm looking for numbers that will multiply together to give me this, and some way add together to give me that. So the 3 and the 2 work. So I have a 3 and a 2 here. This whole thing's equal to 0. To get a positive 6, they both have to be positive, or they both could be negative. But because this is a positive, they both have to be positive. Now that I factor that, what I am saying here is I have that quantity x plus 3 times that quantity x plus 2 is equal to 0. So that means either this thing right here, x plus 3, could equal 0, or this thing right here, x plus 2, could equal 0. If this is equal to 0, 0 times anything 0, and that equation will hold true. Solving this equation, I subtract 2 from both sides to get x equals negative 2. On this equation here, I subtract 3 from both sides to get x is equal to -3. Two solutions, either -2 or -3. I could take those solutions, plug them back in, and make sure they work. And that's always a good idea. -2 squared, I'm doing this one first as a check. -2 squared is 4. 5 times -2 is -10 plus 6 is 4 minus 10, -6 plus 6 equals 0. Yes, it is. That one works. Let me try this one right here. -3 squared is 9. -3 times 5, -15 plus 6. 9 minus 15, -6. -6 plus 6, 0. That one also works. So both my solutions work. It's interesting with the quadratic that there are two solutions. But remember, what we're doing is we are multiplying. When we add and subtract, we're on a singular line, the number line. But when we multiply, we're in x and y. So we're in two dimensions looking for area. So there are going to be two different solutions with an x squared. All right, example number 2. Maybe pause the video, give this one a try, or just watch me work through this one. We'll do some practices in a minute. Only factors of 2x squared are 2x and an x, 2x squared. Only factors of a 2 are a 2 and a 1. But how am I going to get a 2 and a 1 equal to 5? Well, I got to couple one of them with this 2. If I couple the 1 with it, it's going to give me a 2 and a 2. That's not a 5. So it's going to have to be a 2 right here and a 1 right here. This 2 has to be coupled with that 2. When I'm factoring like this, I'm kind of doing the reverse as a check, which was that FOIL operation, multiplying the first, 2x squared, the outer, 4x, the inner, 1x, the last, 2. Well, this is a positive 2, but this is a -5. To get a positive 2, it either has to be positive, positive, and if I do that, I can't get a -5, or a negative, negative. Let me just double check this one more time. 2x squared minus x minus 4x gives me that -5x plus 2. This whole thing set equal to 0, meaning that either 2x minus 1 is equal to 0. I'm going to add a 1 to both sides to get 2x equals 1. Here I am multiplying, so I have to reverse it with division. So x is equal to a half. One of my two solutions. My second solution here is x minus 2 could equal 0. I add 2 to both sides to get x equals 2. There are my two solutions, 1/2 or 2. I take those, plug them back in, and check that they work. All right, 13.2, solving quadratic equations with the quadratic formula. This is just kind of a beast right here, this formula. Step 1 before you do this is you have to put your equation in standard form. So I have to be in this form first. Something x squared plus something x plus something is equal to 0. Once I am in the standard form, then I can use this equation. I know it's crazy looking. If I'm in standard form, I want my a here, my b here, my c here. Now that I have it that way, these are the values I plug into that equation, and that's going to give me what x is equal to. So factoring is easier, but you can use a quadratic equation. I only like to use this after I try and factor. On any standardized exam, it's almost always factorable. Okay, so here's our equation, again called the quadratic equation. I take that b value and multiply by a -1. This plus or minus is where I pick up my two possible solutions. This value plus this divided by that will give me one solution, or this minus this divided by that will give me my second solution. The reason why it's plus or minus is anytime you take the square root, it can be positive or negative. So when I'm saying what is the square root of 4, you say 2, right? Because we usually use it for distance, so it's always positive. But -2 times -2 is also equal to 4. So there are two solutions to this, both plus or minus 2. Okay, so with that quadratic equation here, let's take a look at our first example. Our first example is x squared minus 4x plus 1 equals 0. I want it in standard form, something x squared plus something x plus something equals 0. It's there. There is no number in front, so it has to be a 1. B is this number right here, and C is this number right here. So I'm going to use this equation here. X is equal to negative B. Negative 4 is 4 plus or minus, do that in red there, the square root, negative 4 squared, right? B squared, negative 4 squared is 16 minus 4 times A, 1 times C, 1, all under the square root, all divided by 2 times 1, or just 2. Okay, let me clean this up a little bit here. So what I have here is, I'm only going to do the plus first. 16 minus 4 is 12. So I have 4 plus the square root of 12 divided by 2. Now I'm going to do the negative part, or 4 minus the square root of 12 over 2. Two solutions, and that's where my two solutions come from. Square root of 12 is not going to be an easy number. You could simplify it. You could simplify that square root like for a standard exam. 12 is made up of a 4 and a 3. 4 is a perfect square. So this is the same thing as 2 root 3. So on a standardized exam, it's probably going to be 4 plus 2 root 3 all over 2, or 4 minus 2 root 3 all over 2. Pretty complex stuff. There's a quadratic equation right there. I have another example here. Maybe pause the video and try this example. So in this problem right here, I have 2x squared plus 3x minus 5 is equal to 0. A is equal to 2, B 3, C negative 5. So that is going to give me x is going to be, I'm going to write it out twice here. X is going to equal negative b plus the square root b squared 9 minus 4ac all divided by 2 times a. There's my plus 1. My second solution is x is equal to negative b minus, right, the square root of b squared. 9 minus 4ac all divided by 2a. This is going to be equal to 4 times 2, 8. 8 times 5 is 40. This is all positive. So this is going to be negative 3 minus the square root of 9 minus 40, negative 31, all over 4. Square root of a negative number. This is an empty set. There are no solutions. Nothing times itself will give you a negative. So this answer you discard. This answer right here, we're going to have negative 3 plus the square root of 8 times 5, 8 times 5, 40, positive, right, negative, negative. So 49 all over 4. This is going to be, square root of 49 is 7, negative 3 plus 7 divided by 4. Negative 3 plus 7 is 4. 4 divided by 4 is 1. This answer got discarded. that answer gets kept. Oh, this is wrong right here. And the only answer that works is x equals 1. All right, moving on to section 13.3, the discriminant and its applications. So when we have the quadratic equation, we have x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So this portion right here, the square root of b squared minus 4ac, that's called a discriminant. And as we kind of showed in the previous problem, square root of a negative is undefined, doesn't exist. It doesn't even make sense, right? There's nothing that'll work. So the discriminant will tell you how many solutions you'll have. If this thing right here, underneath the radical, the discriminant, if it is negative, there are no real solutions. Okay? If it is positive, then there are 2 solutions. So if the discriminant is greater than 0, if it is positive, then there are 2 solutions. If the discriminant is equal to 0, this whole thing equals 0. So if it's 0, then there is 1 solution. If b squared minus 4ac, the discriminant is less than 0. If it is negative, then there are no real solutions. The solutions are complex, meaning that they don't really exist. So here is the empty set. So just quick recap on the discriminant. If this thing under the square root is positive, there are 2 answers. If it is 0, there is 1 answer. If it is negative, there are no real solutions. That'll come up in some standardized tests, not that big of a part on the ASVAB. However, all of that factoring and solving quadratics is a very big part of the ASVAB. Okay, now let's move on to application problems that are in 2-dimensional space, quadratics. So here's a case right here. I have a rectangular garden. Its area is 48. The length is 2 feet more than the width. So I think I'm going to call this the width, and this is the length, right? It doesn't really matter which way you label them. And I'm just going to call it x, but whatever this is, it is 2 more than that. That's the hardest part of it. Area of a rectangle is base times height. So I have x times x plus 2. And really, if you're getting these problems right here, you're getting a big portion of this course. This incorporates so much of our previous learning, right? Word problem, laying out the word problem, setting up a variable, area of a shape, then we're at the quadratic, then we're at distribution, okay? Then we're setting the quadratic equal to 0, then we're factoring. Okay, everybody good to go here? Then here I distribute this x through the quantity to get x squared plus 2x equals 48. Remember, however, before I use quadratic, I have to put in standard form. So I subtract 48 from both sides. These are non-similar terms. So that gives me x squared plus 2x minus 48 equals 0. I'm going to try and factor and solve here. Only factors of x squared are x and an x. Now I'm looking for the factors of 48 that are going to give me a 2. So 2 numbers multiplied together give me 48. 48 and 1 won't work. 24 and 2 won't work. 12 and 4 won't work. 8 and 6 will. 8 and 6 multiplied together give me 48, but added or subtracted will give me that 2. That is a positive 2, so the larger number has to be positive and the smaller negative. A lot of steps here. Let me just double check this. I'm going to FOIL it out. X squared plus 8x minus 6x gives me that 2x minus 48. So first thing I did is I converted my sentence to a picture, my picture to an equation, multiplied out the x. Then I recognized it as quadratic and I got it in a standard form. Then I factored it. Now that I've done that, that means either this thing could equal 0 or this thing could equal 0. So that means either x plus 8 equals 0, subtracting 8 from both sides, x is equal to negative 8, or x minus 6 is equal to 0, add 6 to both sides, x is equal to 6. Two solutions, negative 8 and 6. And I could see that this doesn't even make sense. How could the length of a side be a negative 8? That's kind of where that discriminant is working out. So that does not make sense. You discard that answer and you keep that answer. Now that you have that, you plug it in. This is 6. This is 6 plus 2, 8. Let me see if that meets all the conditions. Rectangular garden has an area of 48, 6 times 8. The length is 2 feet more than the width. One side is 8, 2 more than the other side. So it meets all conditions. A lot of math there. It worked out pretty cleanly. A lot of this math is specifically designed so that you don't get to a place where you can guess and check. You might have been able to figure that out of 48 and just gone 24 and 2, 12 and 4. But the problems you're going to get, you won't be able to do that. But this is a good example. All right, here's another application problem of projectile motion. This is a pretty tough one here. The height is given this equation right here, negative 16t squared plus vt plus s. That's our general equation. Then now you're given these pieces right here. V is equal to 64 and S is equal to 80. So I plug those in and I get this equation here, negative 16t squared. Once I have that quadratic, it's set equal to 0. I factor out a common term. I could see 16 will go into all of those. Pull that negative 16 out in the front to get negative 16 times the quantity t squared minus 4t minus 5 is equal to 0. I could divide both sides by negative 16. Those will cancel. That'll make it a lot easier. 0 divided by a number is still 0. So now I have t squared minus 4t minus 5 equals 0. Only factors of t squared are a t and a t. Only factors of 5 are a 5 and a 1. One has to be positive, one negative. To get that negative in between there, it's going to be a negative and a positive. T squared plus t minus 5t gives me that negative 4 minus 5. This whole thing's equal to 0, so either t plus 1 is equal to 0 or t minus 5 is equal to 0. Here, t is equal to 5, t is equal to negative 1. That doesn't make sense, so I cross it out, and there's my solution. I take that 5 seconds, that's what we were solving for, and that's my answer. I could plug it in to get height if I needed to. Not an easy problem. If you get this, you get everything we've done so far. This is tricky stuff right here. Okay, here we are on our chapter test, chapter 13 test. What you want to do right here, again, pause the video, do these problems before I do them. Unpause, watch how I do them. These are all very much set up for standardized math exam. That last one I just did is kind of a bonus, really hard problem. All right, number 1, I have x squared minus 7x plus 10. I want to factor that to x and an x. All right. Funny how when I'm getting to the end here, the pen gets tired, just like the rest of us. So I have factors x squared or x and an x. Looking for the factors of 10 to give me a 7 when added and multiply to give me a 10. 10 and 1 won't work. 5 and a 2 will. They are both positive or both negative, but to get that negative 7, they both have to be negative. This whole thing is set equal to 0. The directions here should really say solve for x. So really the first step is identify this as a quadratic equation. Put it in general form, x squared plus something x plus something equals 0. It's there. Factor with those factors. Either this is 0 or this is 0. So either x is equal to 5 or 2. Two solutions. Okay, number 2 here. Factors of 2x squared are 2x and an x. Factors of a 3 are 3 and a 1, and I need a 5. I'm going to have to couple that 3 with the 2 to get that 6 minus 1. 1's positive, 1's negative. So I want that positive 5x. So that has to be positive, that negative. Let me double check that. 2x squared minus 1x plus 6x gives me 5x minus 3. I double check those a lot because I'm also trying to highlight how I figure them out, going backwards and forwards between the operations of factoring and foiling. Okay, that means here either 2x minus 1 is equal to 0 or x plus 3 is equal to 0. Add 1 to both sides, 2x is equal to 1. Divide both sides by 2, x is equal to a half, or x is equal to negative 3. Two solutions here. Number 3 recognizes perfect square. That's going to be x minus 3, x plus 3 equal to 0. Zero-sum property, either that equals 0 or that equals 0. So here x can equal 3 or negative 3. Two solutions. Number 4, 3x squared minus 8x plus 4 is equal to 0. Factoring 3x squared to 3x and an x. Factors of 4 to get an 8, working with that 3. 12, that's not going to work. 12 and a 1, a 4 and a 1 won't. 2 and a 2 will give me a 6 and a 2, which will give me that. So factors of 4 to give me an 8 with that 3 are the 2 and the 2. Both positive or both negative. In this case, it's a negative 8. Double check. 3x squared minus 2x minus 6x gives me that negative 8 plus 4. This whole thing's equal to 0. That means either 3x minus 2 is equal to 0 or x minus 2 is equal to 0. Adding 2 to both sides, 3x is equal to 2. Divide both sides by 3. X is 2/3, or right here, x is equal to 2. Quadratics, and these don't have it, but remember, first step is always general form. Something x squared plus something x plus something equals 0. All right, let's take a few of the quadratic formula. I won't do them both. I'll just do one of these and then the application problems. So this problem right here is 1x squared minus 2x minus 2. It is in standard form, set equal to 0. A is equal to 1. B is equal to negative 2. C is equal to negative 2. Now I'm going to use my general equation. X is equal to negative b, negative 2, plus, I'm going to do it separately here, the square root of b squared, negative 2 squared, 4 minus 4 times a times c, all over 2 times 1. So there's one of my answers. My other answer is going to be the negative in blue here. Okay? So I have 2 plus, this is 4, 2, 8. Negative is positive. 8 and 4 is 12. Plus the square root of 12 over 2. Or 2 minus the square root of 12 over 2. Those are my two solutions. I could simplify them a little bit. And the way I'd simplify them is simplify that radical. 12 is made up of a 4 and a 3. A 4 is a 2 and a 2. So that red solution could be 2 plus 2 root 3 over 2. This solution would be similar, 2 minus 2 root 3 over 2. Then there's a 2 in all quantities, so I could reduce that to give me 2 will go in here, 1 plus root 3 over 1. I don't need to write it out. 1 minus root 3. And those are my two solutions in simplified form right there. Okay, 7, 8, and 9. If you have the book, the solutions will be down below, like where I skipped 6, so you could check it there. And here, I don't think I'm going to do all of these either. I think I'll just do 2 of them, and I'll leave 8 for you to do on your own and check in the book. The product of 2 consecutive integers. This is such an ASVAB problem because you got to really understand that what that means. So one integer, I don't know what it is, but I'm going to call it x. The next one, if this were 7, what would the next one be? 8. So the next one is x plus 1. So those are my 2 consecutive integers. The product, you got to know what that means. That means multiply is 72. So I have x times my other integer is 72. You might be able to jump and do this one without doing the algebra, but it's a good highlight problem, right? So I could just look at the factors of 72, 36 and 2, they're not consecutive. 9 and 8, see they are consecutive, they're 1 apart, and their product 72. But I'm going to do this with this, just to highlight how to do it. It's going to give me x squared plus x equals 72. I subtract 72 from both sides to set it equal to 0. And I guess by definition, it's going to kind of make sense, hopefully. Factors of x squared are x and an x. Like we said, factors of 72 that are going to give me that 1 in the middle are a 9 and an 8. So I know it's a 9 and an 8. It is kind of what the question is saying, right? What is the product, 72, and then what is the difference when they're by 1? This is positive. This is negative. It's all equal to 0. So here, x plus 9 equals 0. X equals negative 9. Or x minus 8 equals 0. Adding 8 to both sides, x is equal to 8. Minus 9 doesn't work. But 8 does. 8, one solution would be 8 and 9 multiplied together to give me 72. Actually, 9 does work, right? This is negative 9 and negative 8. They are also consecutive integers. It holds true in that. And when you multiply them, it gives you positive 72. So there are 2 solutions. So I guess on the ASVAB, they probably be a tricky one like this, but they might give you both solutions. And if you just figured it out without the algebra, you might have missed that one. Okay. If you're still here, you're doing great. You need a channel, think about subscribing. The goal of this whole course, the goal of all of these videos is for you on math, on any standardized math exam. And I like to be there right there along with you, kind of working through this together, because I know how hard it is to do this stuff by yourself. I know it ain't easy listening to me yarn on, but hopefully it's a little bit better than just doing it by yourself. Okay, number 9. If you get this problem as well, you really get pretty much everything we've done in this course so far. A right triangle has legs of length x and x plus 1. There's my right triangle right there, meaning one angle is right. And a hypotenuse of length 5. Find the value of x. So step 1 is really to draw my picture. That alone is pretty hard. Step 2 is take my picture and create an equation. Well, right triangle is the key word to figure out Pythagorean theorem. So I have one leg squared plus the other leg squared is equal to the hypotenuse squared. A squared plus B squared equals C squared equals 25. This thing is not x squared plus 1 squared. I got to FOIL that whole thing out right there. So this is x squared, this one out front, plus x plus 1 squared, which means x plus 1 times x plus 1. And that whole thing's equal to 25. I'm going to do this portion right here. I got to FOIL it to give me x squared plus 1x plus 1x. Last plus 1. So this blue thing right here is this blue thing right here. Then I still have that x squared in the front of it, and it's equal to 25. Now I got to combine similar terms. One of these plus another one of these is two of them, 2x squared plus 2x. I have to set it equal to 0. 1 minus 25, negative 24 is equal to 0. So we're working through a really long process here. Step 1, convert that sentence to a picture. Step 2, convert that picture to an equation. Step 3, recognize that as a quadratic, and then have that quadratic set equal to 0. Lot right there, right? Next, I'm going to factor out a common term of 2. Pull a 2 out front to give me x squared plus x minus 12 equals 0. Divide both sides by 2. That'll just disappear. Factor that. Factors x squared or x and an x. Then I'm looking for factors of 12. Multiply together, give me a 12, but added together, give me a 1. So that's going to be a 4 and a 3. 1 positive, 1 negative. Wait a sec. It's not going to work, is it? Yeah, it is. This has to be positive, and this has to be negative. Let me double check that. X squared plus 4x minus 3x is a 1x minus 12. It's easy to get lost with so many steps. Now that I factored it, I'm using the zero-sum property. Either this, x plus 4 is equal to 0, or x minus 3 is equal to 0. This is the idea here of the discriminant, x equals negative 4. That doesn't make sense. You can't have length of a side negative. Add 3 to both sides, x equals 3. Here's my answer. This is a 3. This is 1 more, or a 4. Right triangle has legs of x and x plus 1. This is something plus 1 more. That works. And a hypotenuse of 5. 3 squared, 9, plus 4 squared, 16 is equal to 25. Again, if you got that, you are on the right track in math. This is a hard problem that incorporates a ton of skills. And if you're here with me right now, congratulations. You're working hard, making it happen, doing the problems, getting that practice in so that you will be successful on your next standardized math exam. Thank you for watching.